Okay, so I'm going to go over as fast as I can a couple different ways to get your Rev model to print 3D from a couple different programs. If you remember my post from on Square One about the 3D printing process, I really go over what I've been doing in the Lincoln office, but I actually never go through the process on how to go through this to this to this to go from the file to the software to the 3D print. I just kind of go over what we've been working on and how to kind of go about doing it. It's been really great having a 3D printer. I've been doing this for about 10 years now, just a little bit over 10 years. So it's really awesome to have that kind of infrastructure in-house now. But yes, let's take a look at Revit model. In this case, yes, this has been fully modeled in Revit. Fully vetted. It's just a little project I was working on, and I wanted to see if I could get this to print in 3D, and it's been a lot of fun. So one of the things that's really key, that just is overarching, no matter what program you use, Revit, Rhino, Sketchup, is modeling, good modeling techniques. But that's a whole set of another videos on causing the cause of issues. So one really easy way to make sure that you can get a print is to make sure you have enough thickness. So what I like to do is, at this scale, 3D printing this at, say, 1/8 inch or even 1/16 inch scale, it's definitely not going to print very well. So I've got kind of a dummy rectangular mullion in here, and granted, check with your BIM manager and check with everybody on your team to make sure that you do want to go this route. I can show another way to kind of circumvent this, but this is the easiest, fastest way to kind of do this, is to grab everything that's going to be thin in your model and thicken it up a little bit. The other little trick that I have is create an Stl Export. The difference between this view and the standard 3D view and the Stl Export view is a lot of the superfluous, really fine detail, like this railing, that is not in this export, because it's just not going to print that really fine stuff, and you'll get errors all the time. So this is a pretty cleaned up model. You get to see the big concept, and that's what you're really trying to do. If you're printing 3D, you're not trying to get the finicky door handle detail. You're trying to get big concept, big flow, big items, big ticket items across the board, structural, architectural, whatever they might be. And this is a model ready to go. I'm going to jump into SketchUp real quick, go through that process, and then jump back into how to take it from Revit 3ds Max, Revit to Rhino, Revit to Format, those types of things, as kind of as fast as I can. SketchUp, I do make fun of it a lot. I do own my own license for it, so it is something I use, but not typically for just about anything anymore. Shout out to Scott Schiffmiller, the Lincoln office. He showed me this cool little Ruby plugin for SketchUp, which is, since SketchUp isn't a solid modeler, which is really critical that horrific almost that it isn't a solid modeler. So if I click on a face here, it's hollow inside, water gets in there, hence watertight. It's not watertight, but this is a handy little tool. And let's say I had a bigger model or something significantly more detailed. What this will do is find a whole bunch of the little errors for this, and then I manually have to go back and close these little suckers off. That can be very daunting, but again, goes back to good modeling techniques. If you're modeling well, you don't have these issues. You're back into it. Hey, no issues because no errors came up. That being said, the other thing that I've come across every once in a while is reverse faces in SketchUp. Another nightmare kind of thing. Revit doesn't do this. 3ds Max doesn't do this. Quite a few programs don't do this, but for whatever reason, that will sometimes show up as hollow in an STL file. And 3D printer will obviously not read it. So there's another tool out there that will reverse faces, so everything will be solid again, and that's what you kind of want. So again, SketchUp, probably not your number one go to if you want a 3D printed model. Let's see. Let's go back to that just a second. So, and there's no real solution for getting it ready at this point, other than you want the thickest objects to export, no chains, lattices, or extreme detail. You don't, and the other reason is you don't want something so fragile it breaks in the client's hands. So, there's that. Sorry, one more thing. So, file, export, and most people know how to do this. 3D model, get into CAD. Do whatever it takes to get into either you have an Stl exporter for SketchUp and it probably doesn't work very well. I'll throw it into CAD and then take that into Rhino and just file save as in Rhino. You don't need me to show you how to do that. Next up is of course 3ds Max. So I'm going to touch on something else kind of cool that apparently a lot of people don't know about yet or haven't experimented with enough. But let's go ahead and save this Revit model now that we have our thicker mullions here, just real quick, and try not to save in 3D view. And if you have a question on that, let me know. Let's go back to Max here. So if you noticed, this one was a little bit thicker, a little bit bigger. If we simply go into Max icon, References, attach, you'll click File, it'll ask you a whole bunch of questions. Do not combine elements, and then pick the view. You always want to pick the Stl Export view, another reason why I created that view. Hit Attach File, brings the file in, and again, just like an XREF in AutoCAD, you hit Reload, it's going to grab that Revit file, it's going to give you a whole nother list of questions. I always crank this to 15, not to 11, crank it to 15. Auto Smooth Faces. Typically I don't bring these in, and this is again a whole nother lecture series on materials in this. So this takes just a minute, but luckily it's probably enough time for me to go through and show how to do this in Rhino, because this one's probably the easiest on how to do it. So this is that exported CAD file, we'll call it, and basically open Rhino, bring it in. Let's grab our selection here, hit enter. You almost don't need a video for this. I mean, it's as simple as, file name XYZ, and that's about it. It's probably going to ask me for some options here, even before or after. I do like ASCII, but it tends to make larger files, so I've been kind of switching back and forth between that and binary. Whatever gives me the smallest file, I'll typically use. Hit save, and oh, there it goes. Yeah, it calculated it. So that's way too big of a file. Even this seems kind of incredibly large, but that's it. Click OK, boom, there's your file. Upload it to your 3D printer, you're done. Let's check on Max here. Hey, all the mullions are big now. Hey, awesome. So this one's ready to go too. It's nice. Everything's nice and thick. Again, I almost feel bad for showing a video for this, because it's really just file export, go down and grab what you need it to be. File, if I can type, XYZ, and save, and you're off. Upload that to 3D print. So once you get that one done, again, I'm trying to hurry through this. If there's any questions, email me, but that's pretty much it. Format's my next newest favorite, I guess. This one's really nice because you can always quickly, if you're modeling in this or importing Revit into this, and again, I can show you how to do that, but there's YouTube videos for that. This will always automatically tell you watertight issues. So as you're modeling, it'll tell you whether you're modeling for water tightness, STL, or not. And then again, file export, STL, boom, you're done. Upload 3D printer. Of course, once all these things are fixed, and if I'm not mistaken, since this is kind of new, this will actually fix those issues for you. I could be wrong. Okay, it's saving. The desktop version of Format just came out like a week and a half ago for the first time ever. So there's a couple extra things in here that they've switched around, but I thought that there was an auto hole fixer, model fixer. But if there isn't, don't worry, there's yet another program. So let's take a look at MeshMixer. So this is a free program. This one is on just meshmixer.com/download. Grab the 64-bit. guy right there, download them, you should be good to go. So this one's actually pretty interesting because it'll bring in all this geometry, and you can modify it. You can add thickness to it. You can inspect the element for water tightness. Obviously, I have the quote-unquote same issues in Formant that I have here that I have in the other models. The great thing about Rhino and 3ds Max is it tends to, doesn't always, but it tends to just automatically fill those gaps. But luckily, this is sort of built into this program, and then I can tell it, oh, what's acceptable and what isn't acceptable in terms of how do I want to say this, how thick I want that material to be auto-adjusted to. So in this case, let's just take a look at what happens to this when I really thicken it up. It's going to take a wet material. We don't want that. We don't want just this turtle shell here. We want, you know, all the beautiful concept of all these shading devices here. So let's take a look back at inspection here. Let's take that threshold down. This isn't going to help me a whole lot, but it might get those fins back in, and then auto repair it. And what I like about this is fast. I mean, this is pretty efficient. I can get those mullions in, but again, it's good modeling. I need to make those mullions thicker, so now I know that I have to go back into this Revit model and yet again, make those, you know, maybe they need to be 12 by 20. Whatever it takes for this to not delete them out. But so far we're pretty close right off the bat, so hopefully that's not too big a deal. And then luckily with this program, this works right with our DLR Group's Autodesk Ember, which is sitting right behind me. I can just print up to this. There's a whole another, obviously it's a smaller test bed and everything, but if it does find any errors after that, it'll just repair them. You add some supports, and then you up and printing. So there's that one. I'm not ready to do that yet. Go ahead and minimize this. And that should just about do it. Showing a couple different examples on how to get your files to print. If you still can't get it to print, reach out to me. I can get it to print somehow, some way. I will find some way to get that 3D model to print. Otherwise, there should be another system here. Oh, no, it looks like I covered them all here. If not, you should be able to end up with that. And this is printed out of a Stratasys 5000, DLP 5000, so really, really good. You know, obviously you see some segregation of the elements there. Some, you know, when you run your fingernail across this, it goes da 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 da. But more or less, it got all the detail, and this is really an incredible model. Go back to whoops.
You probably should ignore that.
So let me close this real quick. That's a Dynamo, and that's a whole nother set of tutorials, but didn't mean to bring that up. Anyway, that should just about do it. Take a look, and if you got any questions, reach out to me. But hopefully this explains the process behind getting a model ready and getting those all exported. Great, thanks.